So today let us see how we can use a library called Pandas with Matplotlib. As most of the time in the real world, you won't be handling data which is very small and most probably would not be just working with small lists or dictionaries, etc. So for example, here we have a data about a lot of students and their grades in different subjects. So how can we analyze this using Matplotlib and with all the bar charts and scatter plots that we have learned till now? So first of all, let's import that library. So import pandas as PD. So if you haven't already, you would actually also need to install this library using the pip command. So you could run the command pip install pandas. So there, that would install this library for you. So over here we are importing pandas as PD. So this is just a shorthand that we can use to refer to pandas. So in Pandas, we have a structure called a data frame, which is very similar to a table which has rows and columns. And if our data is structured in this format specifically, which is a list of dictionaries, it is very easy to create that data frame. You could simply just call the data frame method from the Pandas library. And then we pass in the data from which we want to create the data frame. So, okay, I didn't print this. So now if you want to see what data we have, you can just print this data frame. But the data frame also has a very handy head method, which shows the first 5 rows of the data frame. So now if we run this, we can see we got a nice table over here with the columns as the subjects and the index as the names of the students and their score in each subject. So now it is much easier to analyze. So let us start with this. So let us say that you want to see the average score for each subject for all the students. How can you do that? So in Pandas, we have a lot of functions that we could call that run aggregate upon all the columns. So for example, if we say student average equals to df dot, and then we give it a list of the columns, English, you might be wondering why we do have to give a list of all the subjects over here like this? Because since name is also a column and we can't calculate average of a names. So dot MEA and mean. So now this will give us a simple data frame where the indexes would be the names. The indexes would be the column names, which would be the subjects, and we'll have the entry of those as another column of average. So by that, what I mean is, let's see, let's print this. print print average student. Yeah, we don't have a dot over here. So as you can see over here, for the English, this is the average score for maths, for science, for history, for geography. So now it's really easy to plot. So similarly, like we did before, we can just plot this with PLT. PLT dot plot. We have the indexes, INDEX index, and we also have the values. So let's try running this. So as you can see, this is the plot of all the average scores. But over here as well, A line chart is not very useful in seeing what the average for each subject is, since the data is not connected and the line chart connects the different subjects. So what we can do instead is called the bar method. So what this would do is instead make a bar chart. Yeah, so as we can see, this is much more informative. Over here, we can see the average for English was the highest, and for the maths, it was the lowest. So now, what other info can we explore in this data using the Pandas data frame? So as you might remember from the last video, we can also use scatter plots to see the relation between two variables. So what if we want to explore if there's any correlation between the scores of maths and the scores of English? So let us go ahead and do that. So plt.s scatter the score for maths and the score for English. And we'll just make the x and y labels to make things more clear. And also, if you remember from the last video, it's always great to make the axis equal so it does not distort the data. So now if we run this, now here we can see that there is a positive correlation between the scores. The students who scored higher in English generally also scored good in maths. There are some outliers as well, like over here, some students scoring very good in English but average in maths, but in general, there's a positive correlation. So that's one thing we could do. So what else? Let us explore this data more. Okay, so now what if we want to see if there are any outliers in the science score and how generally is the science score distributed? So for that, we can use box plots. So plt.boxplot.df sciences and plt.show. Okay, so now this is a box plot. So for a refresher on what a box plot is, in a box plot, this is the highest score over here. So the highest score for science is 90 and the lowest is 40. And this is the general distribution of the score. So this is the mean score over here marked with this orange line. And this over here is the 75th percentile of the scores. So what that means is that 75% of students got a score which is lower than 85, which we can see. And so and this over here is the 25th percentile. So what this means is only 25% of students got a score which is lower than this. So this is also very useful when you're exploring any data and generally want to see that how the data is distributed. So over here, as we can see, uh, there are more outliers, or to be more concise, much more extreme outliers in the lower direction. So the score over here of 40 is very further away from the general distribution of scores in science. So there are some students who are scoring exceptionally low. What if we want to explore the distribution of the geography scores as well? As we can see, we can use a box plot to explore the outliers and the general distribution of data, but we could also use a histogram. So what histogram does is it's very similar to a bar chart, but it divides the data into different categories and shows us how much data is in a specified category. So for example, let us say we give it the data of history, and instead of a blocks plot, to plot a histogram, we just use the hist method, hist. And for that, we also need to give it the bins argument, which is the number of categories, the number of categories or the number of bins it will divide the data into. And let's also give it a title just to make things more. Now, if we run this, so as we can see in this graph, there are around two students who got scores which are between 25 and 35, uh, 37. So between 24 and 37. One student each for starting from 37 to 62. Two students from 62 to 74, and only four students who got marks between 74 and 84. So this is another way to see how your data is distributed. So as we saw, this is how you can use Pandas library to get together with Matplotlib to explore your data. But most of the times you won't be getting the data as a list of dictionaries or in your code. You would actually be reading it from a CSV file, or rather any other data source online, or a Parquet file, or etc. So in the next video, we'll see how you could actually read data from files, and we'll try to explore a open source data set from the start to finish.